So the first practice worksheet is, let's consider a problem where charges are not placed on a straight line, but rather they're actually placed on a plane. Let's consider a 2D electrostatic problem. By the way, what does static mean? Moving or not moving, when something is static. So basically, in this course, we do not do electrodynamics, we do electrostatics, which basically mean charges that have not been allowed to move yet, okay? So the distance is not changing, okay? Or there's no motion in real time. Okay, so here's the problem. So how many charges do you see? Each sphere is a charge, so how many charges? 3, okay? In any problem like this, everyone, in any problem like this, whether in grade 12 or in first year, whenever they give you a bunch of charges, the question will always be the same. Fix all of them except for what? Except for one. So basically, you'll always know or assume that out of 3, 2 of them are held in the same place. How? Doesn't matter. Maybe they're way too heavy or they're mounted on poles. It doesn't matter. 2 of them are not allowed to move. And only how many are always allowed to move in any system? Just one. Because there's only one that's allowed to move, they have a specific name for that. They always call it the test charge. The test charge. Because it is the charge that tests the what? The environment of the situation. Okay? So obviously, if I can fix 2, how many people took data management here? Do you see how I could turn this into a data management problem? How many possible problems could I actually make up of this? Depends. For each time, you could only allow how many to move? 1. So if I allow this one to move, that means I have to fix which 2? The upper 2. That's one problem. I could allow this one to move, which means which 2 get fixed? The diagonal ones. I could allow this one to move, which means what? Those 2 get fixed. So I could actually give you how many problems out of this? 3. Depending on which one. Technically, they're all the same way of doing, but depending on which one I fix, it might lead to a different geometry. Okay. Ali, what's the question saying? Go ahead. Uh-huh. Yes. So out of all of these, the test charge we are allowing to move is, oh, sorry, this is not the slides. So we'll talk about the worksheet now. We're doing the worksheet. Yes, the first worksheet number 1. So which one are we allowing to move? The 3Q, the 2Q, or the Q? The Q. Perfect. Okay. So here's my question to you. The first thing we have to know is, which way is the Q gonna be pulled or pushed according to each one of the other 2? How do you think those 2 are gonna interact? Are they gonna repel or attract? Those 2. Those 2 are gonna attract. And since this one doesn't move, how does this one only move? Down or up? Perfect. So the force on this one by this one is going to be directed exactly this way. All right, done with that. Now let's do this pair, this one and this one. How are those 2 going to interact? Attract or repel? Repel, because they're both what? They're both like positive charges. So how would this one move if there was nothing else in the problem but this one and this one was fixed? How would it be pushed? Inward or outward? Exactly. Okay, perfect. So the first thing we're going to do, go ahead. So let's actually, on the diagram, go ahead, on the system diagram, not the FBD yet, not the FBD. On the system diagram, the force pulling this up, or acting up on this, I should say, for a neutral comment, is F minus 2Q on plus Q. By the way, feel free, if you don't want to write so much in the subscript, feel free to number your charges, like 1, 2, 3, and then you can say like Newton's third law, FA on B or F1 on 2. Okay? Maybe we should have started doing that. Let's do it in the second problem. But for this one, let's actually call it what it is. Force of negative 2Q on plus Q. All right, that's it for this force. How is the other one going to be directed exactly? Which way? Kinda? Is it going to be up or down? Can you guess the angle, though? I'll give you a hint. This is a right triangle. This is basically this triangle. This triangle. So this triangle definitely has what? 45 degrees. Yeah. By the way, this is a physics course, not a math course. So I'm not always going to ask you to show me the work on how you figured out the angles. Okay? If you can figure them out, that's absolutely fine. So go ahead. Sketch what? Do you have actually a line sketch? No. Perfect. You do have it. And why is it dashed? By the way, Are any of those lines actually existent? Like, are there actually rods connecting those charges? No, there doesn't have to be. So I don't really care if you make all of them solid or all of them dashed. Okay? Okay. Which way are we going to put the force of 3Q on Q? Which way? Exactly. It's not going to be in the line or on the line. It's going to be going outside. So everyone, go ahead. Yes. There you go. And the subscript should be F3Q on plus Q. There we go. 3Q on plus Q. Okay. Can someone remind me again yesterday what is Newton? So not Newton. So used to Newton's gravitation. What is Coulomb's law? Like, what's the form or the formula? Come on, everyone. Ali. I'm sorry. I mean Ahmed. K Q1 times Q2 divided by what? So we need to know this distance. How can we know this distance? The what? The Pythagorean theorem. Okay. What would it be? Yes. By the way, before Josh says it, by the way, everyone, did I give you any numbers in this problem? No, I did not tell you how long the triangle sides are, and I didn't tell you how big the Q's are. Get used to this way of being given electrostatic problems in first year. They always give it to you in terms of what? L's and what? What two variables do we have here? L's and Q's. I'm going to show you some pages from the university textbook now. Almost they never give you numbers. Or they give you number, but when? At the end of the problem. But they require you to do everything symbolically from the beginning. So, Josh, what would this distance be in terms of just L? Root 2L squared. But technically, oh, sorry. Yes, you said root 2. Absolutely. All right, everyone. Oh, my bad. Oh, sorry. I thought I had it. Okay, so let's actually write something here. So, what's the Pythagorean theorem? A squared plus b squared, or c squared equals a squared plus b squared. So this will be L squared plus L squared. But everything has to be under what? Square root, which is equal to okay, what's the square root of this guy? Now, which one of those two things has a perfect square root? The 2 or the L squared? The L squared. What's the square root of 2? Just what? If anyone asks you, what's pi? What should you just say? Pi. You should never start saying the number because pi is supposed to be a what? Not supposed. Pi is actually a what? An infinite number. And all square roots of non-square rooted numbers are what also? Infinite. So if you want to keep everything exact and someone asks you what's the value of root of 2, you should just say what? Root of 2. Then you're 100% exact. So this is just what? Root of 2 L. Exactly. Thank you. Perfect. Okay. Now we have to start with what? With the actual FBD. So we just finished this one, whatever that is, blah, blah, blah. Okay. Okay. So let's put the FBD. So obviously this is my Y and this is my X. Okay. Where's my first force? Which way is it pointing? Come on. Yeah, up, straight up. Okay. So let me zoom in for you. All right. So my first force is straight up. And we're going to call it F negative 2Q on Q. Okay. About the next one, what was the angle exactly? Yeah, 45. So just try your best to make it somewhere half in between the quadrant. Okay. How many good vectors do we have? Good vectors. How many bad vectors? Great. Let's break down this this tilted one. So F 3Q on Q. All right. Break it down. Break it down. So we can call this F 3Q Y and this F 3Q X. And both angles are what? Both of those angles are what? Yeah, so we're in the habit always of usually taking the what you call it, the horizontal angle. Okay. Which direction should be positive, right or left? Which direction should be positive, right or left? How many people say left? Yeah, why? Because the only force on the horizontal is the one on the left. So go ahead and just put a plus here. Okay, which one should be positive, up or down? How many people say down? Again, it depends on which one wins, right? If this one is longer, then maybe we should put this one plus here. If this one is longer, where does the plus go? Did it matter ever since we did forces? Does it matter which? No, it doesn't, because according to what you pick, you're going to get the right answer. You just have to interpret the sign. Let's actually put it down, okay? Okay, now we're ready. So, how many dimensions do we have in this problem? Come on. 2. Doesn't matter which one you start with, you have to do both dimensions. However, which one of these have fewer forces on it, the x or the y? Great, let's start with the x-axis. So, F net on the x. I'm going to zoom out so you can see the whole thing. Okay, so x-axis. X-axis. Is this a sine or a cosine? This guy. It's a cosine because it's adjacent to the 45. Perfect. So we say F net on the x is equal to F. Which one was it? It was the 3q. Oh, 3qx. Okay. It was F3qx, which was equal to what? Sorry, F3qx, which was equal to F3q on q. You said it, cosine of 45 degrees. Okay. Nothing fancy so far. I'm just doing trigonometry. Now I'm going to put the equation. What was, Ahmed, what was the equation again for the force between two charges? Like what's Coulomb's law? K, all right, everyone, equals K. What times what? Q1 times, what's Q1? 3Q, right? That's my first charge. What's my second charge? So you just put 3Q times Q. Can someone tell me what goes down here from the equation yesterday? Distance what? Good news. Distance squared. What do you get when you square back root of 2L? You get what? 2L squared. Which is why from now on, if you ever on your solution, you show me this. Look, I'm going to show you a little shortcut. If you just show me this in your solution, I'm going to let it slide. Technically, for a length, you should take the what? You should take the what? The square root. But you know you're going to end up what? Squaring it. So as an intermediate step, you can skip that. Feel free to just get up to here and even leave it on the diagram. Technically, that doesn't make sense because do you know what you measure using anything squared? What do you measure using squared? Area. But we want what? Length. So how do you go from area to length? You what? You square root it. I don't need to see that because we're going to end up what? Squaring it anyway. So you are more than welcome to just, skip that step. All right. So over 2L squared times what? Cosine. Okay. Can we clean this up just a little bit? Just a little bit. By the way, I urge you not to put the value for k. Does anyone remember the value for k? It's 9 times 10 to the 9. You know what? Let's just keep it k until the very end. So what's the only cleanup I can do with this? Only a couple of things. That's it. Go ahead. I can multiply. What's 3q times q, by the way? 3q times q. 3q squared. So let's clean up. 3 times cosine of 45 divided by 2. Let's just get the number done. So 3 times 45 cosine, which is 0.7, yep, divided by 2. Great, that's it. You might say, whoa, you barely have any, like we don't have any sig figures in this situation. Fine, you know what, let's take 3 sig figs. So let's just go with 1.06. So 1.0, sorry, 06 q squared over what? Over what? L squared. Yep. So I multiplied 3 by cosine divided by 2, giving me this number. And then I keep the k, the q squared, the L squared. That's all. What's my next step? Come on. Y-axis. Okay. How many forces do I have on the y-axis after the breakdown is accomplished? 2. One of them positive down, as we chose, and one of them negative up. All right. Question. The positive one down, instead of cosine, it's got to be what? What's it going to be? Sine. Okay. So F net on the y equals positive F3QY minus F what? This guy. Yes. Bless you. Okay. Equals. Zoom in so you can see. Now can I plug in the equation? Yes, I can. The K, Q1, Q2, all of that. All right. Hold on 1 second. Okay. Yeah. K 3Q times Q over 2L squared. Let me make the L bigger. Sine of 45 minus K. Okay, here's my question now. What should go on top of this fraction? Raise your hand if you'd like to say the answer. Because there's a small thing you have to watch out for that you actually don't need to do, but many people make a mistake of doing it. Ahmed, what would you put on the top of that fraction? Should you put the negative? What do you think? It is negative charge. I want you to look through your notes from yesterday. Look at Coulomb's law. There is something in front of the equation that I wrote. What did I write? Look at your notes from yesterday and look at Coulomb's law. What does it say in front of the equation? Yep. Hussam, what does it say? No signs needed. Do not put signs. You already used the signs to analyze the what? To analyze the what? Exactly. You already used the signs to tell yourself which way the forces are going. So the only thing you should worry about now is just the what? Direction or just magnitude? So please, whenever you are applying this equation, do not put the signs in the math. You've already worked out the effect of the signs. Does that make sense? We've already said this one pulls this way, this one pushes this way. Good. Now let's just worry about the magnitudes. So instead of negative 2q times q, what should it just be? 2q times q. Yes. It's a battle of magnitudes now. not direction. 2q times q. Okay, distance. What's the distance between? Actually, it's easier to go here. What's the distance between 2q and q? From the L. But it has to be what? You got it. What was your question? You wanted? Oh, sure. Yes. So just L squared. Okay, let's clean up. By the way, do you see a lot of common factors between those two terms? What common factors do we have between those two terms? We got the k's. Well, we got the q squared, and we got the what? The L squared. Okay. Well, you know what? Then let's, hold on. Okay. So if you want, you can take the common factors right now. K, q squared over L squared. Everyone, say hello to the same common factor you can always take out in every single problem in this course and in first year. You're always going to be able to take k q squared over L squared because the problem is always going to be given to you in these terms. Okay, what survives? Can someone tell me what survives from this one? The 3 times sine of 45 divided by 2. What's the good news about cosine of 45 and sine of 45? It's the only angle with the same sine and cosine. By the way, that's why the tangent of 45 is just what? Tangent of 45 is sine over 45 or cosine of 45. And because they're the same, 45 is the only angle with the tangent of 1. So 1.06, basically, it's the same number from before. Minus, can someone tell me what survives from here? After you pull out k and q squared and L squared, what's the only thing that survives? Yeah, technically, nothing. 2 over 1, so just 2. Ooh, are we going to get a positive or a negative number here? We're going to get a what? So which direction is going to win? Down or up? Is that really a big problem? No. By the way, you want to go back and flip this to positive and flip this to negative and change your. If you feel more safer that way, feel free to do it. No problem. So it's what? Negative? Negative what? 2 minus 1.06 is 0.94. Negative 0.94 k q squared over L squared. Just gonna clean this up. Equal sign in the middle? Oh, because I'm cleaning up. Like I'm just. Are you talking about this equal sign? Oh, just like here. I'm just basically finding out the. Oh, hold on. Oh, sorry. I want to point to the F. Yep. I'm just trying to find out what it is in terms of k, q squared, and L squared. Yes, Ken. Go ahead. I know this is a lot of symbols jumping your way, but this is the worst symbolic computation they can give you in first year physics. Go. Oh, actually, you know what? My bad, everyone. Maybe. Okay, let's change this one to what? It's the same. It's the same. But just the what? Because this one looked like a fraction and the other one looked like a multiple times a fraction, they are the same thing. Okay. What do you always do when you find the f net on the x and the f net on the y? What do you always do after? From the again? The, before the angle. I mean, you could do the angle, but before the angle, the Pythagorean theorem, find the hypotenuse exactly. So, everyone, final statement for the magnitude is this. F net equals square root of what? 1.06. There should be a dot here. 1.06 k q squared over L squared, all squared, plus what? Okay, come on. Do we really need to include the minus? You're going to what? You're going to square it. You can skip it if you want. So I'm going to skip the minus. Uh, Do you want to see a very, very neat trick now? Isn't this a common factor between here and here? What do you get when you square something and then square root it? What do you get? You get the same thing back. You know every time you can pull out of the square root, you can take out all of this, and because the square will be canceled, every time it will just be this. Just the numbers. Every time. What is that value? I don't know. 1.06 squared plus 0.94 squared equals, and then don't forget to square root the addition. 1.42. That's it. That's it for the magnitude. How can you find the angle? What do you divide by what? Always. The y by the x or the x by the y. If you always want to get the horizontal angle in your final answer. You say again? Y over x. Thank you. So theta equals tan inverse of f net on the y over f net on the x. Okay, can someone tell me what's the f net on the y? Just read it for me. What was the f net on the y? By the way, ditch the minus. Don't care about it. 0.94 times what? K q squared over L. What's the f net on the x? Come on. 1.06 times what? K q squared over L. When you divide those two numbers, what things are going to cancel out? The k's, the q squareds, and the what? And the L squared. What's the only thing that's going to remain? The what? The value, the coefficients or the numbers. So please feel free to jump ahead and just put the 0.94 divided by 1.06. Again, I'm showing you shortcuts that I know once I talk about, you understand why they happen. 0.94 divided by 0.106. That's got to be less than 45 degrees. Yep, 41.5.6.